Hi kids, welcome to a new weekly science lab video. Let's keep on studying the properties of materials. This time we're going to focus on electricity in relation to materials. Electric charge is the physical property of matter that causes it to experiment a force when placed in an electromagnetic field. There are two types of electric charge, positive and negative. By convention, the charge of an electron is negative, while that of a proton is positive. Charged particles whose charge have the same sign repel one another, and particles whose charge have different signs attract. An object with an absence of net charge is referred to as neutral. The electric charge of a macroscopic object is the sum of the electric charges of the particles that make it up. This charge is often small because matter is made of atoms, and atoms typically have equal numbers of protons and electrons, in which case their charges cancel out, yielding a net charge of zero, thus making the atom neutral. An ion is an atom or a group of atoms that has lost one or more electrons, giving it a net positive charge, that's a cation, or that has gained one or more electrons, giving it a net negative charge, and we call it an anion. During the formation of macroscopic objects, constituent atoms and ions combine to form structures. Thus, the macroscopic objects tend towards being neutral overall, but they are rarely perfectly net neutral. Sometimes macroscopic objects contain ions distributed throughout the material, rigidly bound in place, giving an overall net positive or negative charge to the object. Also, macroscopic objects made of conductive elements can more or less easily, depending on the element, take on or give off electrons, and then maintain a net negative or positive charge indefinitely. When the net electric charge of an object is non-zero and motionless, the phenomenon is known as static electricity. This can easily be produced by rubbing two dissimilar materials together, such as rubbing amber with fur or glass with silk. In this way, non-conductive materials can be charged to a significant degree, either positively or negatively. Charge taken from one object is moved to the other material, leaving an opposite charge of the same magnitude behind. There is a law of conservation of charge that always applies, giving the object from which a negative charge is taken a positive charge of the same magnitude, and vice versa. Interesting, right? Let's put it to test. Roll up your sleeves, for it is experiment time. First, prepare about 20 small pieces of paper, roughly half a centimeter in diameter. You can use a paper punch to get them. Spread the pieces of paper on a table. Then, if you happen to have amber and fur, or glass and silk at home, just rub one on the other. If not, we'll manage with a balloon, which you will inflate and tie, and then use it to rub your hair several times. It is important that the hair is not greasy. Now hold the balloon over the little pieces of paper. What's going on? Exactly. By rubbing the balloon with your hair, the hair has transferred electrons to the balloon. So while the hair has got temporarily positively charged, the balloon's rubber has got negatively charged. In fact, if you bring the balloon close to your hair again, it will move towards the balloon, trying to stick to it by the attraction of opposite charges. By bringing the balloon close to the papers, whose electric charge was neutral, the negatively charged balloon now gives up its exceeding electrons, charging the papers negatively and recovering the balloon's electric neutrality. Therefore, the paper jumps. At first, they are attracted by the balloon because their charge, although neutral, is relatively positive compared to that of the balloon. Finally, the papers also recover their charge balance due to the contact with the atoms and molecules in the air. You can get creative and test these effects of static electricity on other materials by bringing a negatively charged balloon close to a stream of water running from a tap, or to an empty lying aluminum can. Give it a try and tell me what happens. I hope you like this activity. See you!